If you can hear me, signify, please, so I will know I'm live.
Okay.
Okay, thank you very much. So,
Yeah, we can hear you.
yeah, thank you. So, okay, recorder is on.
We can hear you.
Yeah, I guess it's your network that is playing with you. I asked that question like 10 seconds ago. Anyway, so I was saying something about you should prior to this section, you should know what data structures are. Practically, you allocate when you talk about data structures, I'll just give you the examples of data structures we have. We have the array data, we have arrays, those are the kind of data structures. We have stack, we have the queue and the likes of them structures or data structure, anything concerning or multiple data where you store and manage data, okay, in an organized structure, something like that. So now when you talk about memory allocation, for when you declare a variable, you're storing data for a C programming language. When you assign data to a variable, but you value to a variable, that value is a form of data, whether be in terms of a character, integer, or float, or any kind of data that you're assigning to that variable. When you declare a variable in C programming language, that variable takes up a memory address. Okay, that memory address is also known as what the memory location of that variable. Okay, at this particular location inside the memory, the address is pointing at the memory at which that value is being stored in a particular variable of that variable per se. Okay, so now sorry. Okay, I want to start sharing my screen now, so we can just go right into the business of the day. So before we go further, I'm just going to use a Jamboard for now, or probably I'm not a fan of using Jamboard, but I'll try to explain some few things with this on Jamboard. Okay, this was the previous one. Let me just open a new one. So as I was saying, so now when you talk about memory allocation, it's just you allocating a particular memory. Okay, now the memory is either allocated in two forms. Is either allocated we have the static memory allocation, and you have the dynamic memory allocation. I'm going to give you an example of a static allocation. That's the one, a static memory allocation. That's the memory that you allocate during the compile time. Okay, memory allocated during the compile time is called static memory allocation. Okay, and here is an example. Now taking an array for a case study. Okay, hope you can see my screen. So before we start on writing code, I'm just going to start with this guy. Oh, it's because I'm using a very large one this time. This is not what I wanted. Okay, so taking an array, for instance, you have an array of integers. Okay, let me just say this is how you declare an array, right? With this square bracket, and this array is containing some kind of data. Okay, this is arrays of integers. You can only store, when you talk about array, you can only store values of the same data types in an array of a particular data type. So the elements that this array can contain will just be integers. You cannot pass in a float element inside an integer array. Okay, you already know that. So for instance, I'm just going to use 1, 2, 3, 4, 5. Okay, let me just say 1 2 3. Don't let us go too wide. Let me close this. So now for this, now how many elements do you have inside this array? You have what? 3 elements. That's why we have what? Now this is the size of what? This array. Okay, you are allocating this particular size to this what? To this what? Array. So that means this array can only contain what? 3 elements. You can't have what? More than what? 3 elements. For a static memory allocation, this is an example of a static memory allocation. The size of the array is fixed. It cannot be changed. You can't increase it or decrease it during the what? During the runtime, unless you come back before compiling. You come back and what? Change the what? The size of the array. That's manually changing the what? The size of the array. That's is the programmer that is what? Assigning the what? The size of the array size. And in this case, it is not flexible enough. What if you have in a case whereby you want the user to actually like enter the number of what? Elements that your what? A particular array can contain. Okay, in a situation whereby you want the what? You want the user to enter the what? The amount. You want the user to enter the size of the array, for instance. That is where the use of what? Dynamic memory allocation. Okay, for this is what I meant by this is an example of a what? A static memory allocation. Let me just use MA. I'm going to reduce this a bit. Let me enlarge it back. So
I think, won't the array size be 2 or would it be 3? Would it still be 3?
What do you mean?
I mean the size of the array, that is ARR into bracket 3.
Yeah.
Since the number of elements, if you say 0, 1, 2, that's what I'm asking.
No, those 0 1 2 is the indexes. That's the index. That's like the position of each element inside the array. The array contains what? 3 elements, which is what?
Okay,
This is
noted.
first element, second element, third element. But if you want to access each element of this array, you use the index position. That means this first what? Element is at what? Index 0. The second element is at index 1. And the third element is at what? Index 2. So let me
Okay.
just put it like this. Yeah. So this is what it is meant by what? A static memory allocation. You can see is the what? Is the memory allocated during the what? The compile time. You allocated this before what? Before compiling the what? The program. That means what? It is fixed during the runtime. That's when you compile, when the compilation process is being done, is being carried out. That means what? Whatever this size of the array is fixed, no matter what. Like for instance, now you want the user to pass in what? The element of this what? Inside this what? Array. Probably you want the user to add some certain what? You want the user to enter some certain number of integers, and you want the user to help the user to add the what? The numbers, the integers that is being what? Passed in into the array. Now you are the one what? Putting this size. Okay. Now what if the user enters more than the size or less than the size? Okay. That means if the value stored by the user inside this array during the runtime is less than the what? The specific size of the array. Like now we specify that what? This array is what? 3, and the user enter what? 2 elements. Don't worry, we are going to show this practically. I just want to explain before we jump down into writing of the code. Okay, so theoretically this is the explanation. We are going to go into the practical aspect very soon. So now, what if the values that the user enter during runtime is what? Is less than what? The size of the array. Like probably the user entered what? Just 2 elements instead of what? instead of 3 elements like we have here, for instance, you are going to get you won't have error. It's still going to what? It is going to run. Like for instance, you have this. You are wasting memory when you have. Okay, probably. I hope you guys can actually understand what I'm saying, or do I need to type it out? You guys can understand what I'm saying. So when you, if the values stored in a particular array by the user during runtime is less than the specific size of the array, that's the array specified by the programmer, then you are going to be wasting, there's going to be a wastage of what? Memory. Okay, just like you, for instance, you want, probably you are asked to submit a project with a, and your project is, you are asked to submit your project with a flash drive, and your project is just probably the size of your project is just 2 gig, for instance. You can't go and buy 8 gig hard drive or 16 gig hard drive, because you are going to submit the hard drive, or in a normal sense, you are submitting a project of 2 gig. You can't go and buy 4 gig or 8 gig, or okay, let's just say your project is 1.8 gig, for instance. Your project is 1.8 gig, so you rather buy something close to that. You know, you can't find 1.8 gig exactly, but something relatively close to that is just thought to buy a 2 gig of flash drive and then copy your project inside and then submit it. And that way it's just a minute memory wastage you have there. But I'm just using that layman explanation. But for a normal, it will be abnormal or weird unless you have much money to waste to go and buy a flash drive of 16 gig or 32 gig or 120 gig or 128 gig to submit a project of just what? 1.8 gig. You look at the difference. You just wasted money. You've wasted the memory, the free memory that are there that can be used for something else. You know, they'll just use, once they've seen your project, they'll just dump the flash drive somewhere else. Nobody will use it. So that's just the case for this one. So if the user passing like 2 elements for here, you are going to have wastage of memory. That means what? There's still one memory. There's still like, out of these 3, you only use up 2. There's still 1 left that you did not allocate an element to. And another case is where you have the user inputting more than what you specify, more than the size of the array that you specify. Let's say, for instance, the user came and what? I'm passing like, okay, he wants to do this, even though you told the user to enter just 3 numbers, probably with ignorance or something, the user entered what? 4 numbers. You are going to be your program is going to crash or probably misbehave depending on the system you are working with. You're going to get some kind of error. So in order to fix this kind of issue, you know, now your program is not flexible. That means is not flexible to the user side, So in order to solve this issue, that's where what? Dynamic memory allocation comes in place. Dynamic memory allocation comes in place. Okay, and in simple definition, it's just the process of allocating memory at the time of execution. So the memory is not being allocated by the programmer. The memory is being allocated at the time of what? Execution. When the program is being executed, that's where the memory is what? Is being allocated by the use of what? Inbuilt functions, some certain built-in function rather. We have some certain built-in function that can dynamically allocate memories for us without us using doing it in a static way. We assigning the memory of the array ourselves. And those functions include, we have malloc, which stands for just memory allocation. We have calloc, I think it stands for some people call it contingent, or some people call it clear allocation. I don't know, but it depends. Whichever material that you're using.
Contiguous or something.
Yeah, some call it contiguous. I've seen where they call it clear allocation. Okay, then we have the realloc. That's you are trying to do. I will explain each of these things. Okay, then we have the free. Okay, probably let me just do this. Where is this box? Okay, so now we have, why is it's too big? So the built-in function that are going to help us allocate memory dynamically, they are what we call the malloc. You know, their functions. We have the calloc, we have the valloc, and we have the free. So these are, let me just say, built-in functions to built-in functions to dynamically allocate, yes, call it allocate memory. Okay, these are built-in functions to dynamically what allocate memory. So when you talk of malloc, you just mean what? You are just what, doing a normal what memory allocation. That's just what malloc stands for. Malloc stands for what? Memory allocation. So I'm just going to do some little typing here before we go to the view, before we go to live example. Okay, this stands for what? Memory allocation. And it is used to allocate memory at one time. That's doing execution. Okay, memory allocation, which is being, we have this function in a standard library called what? In the standard header file. It's been declared and defined. It's been defined in a standard header file called what? This guy, stdlib.h. This is where you find what? These functions. Anything concerning what? All these are memory allocation functions. They are found in what? This was standard what? Library, stdlib, this standard header file. That is where they are being what? Defined. Okay. So basically this malloc is just what? It's just for you to allocate memory at what? At one time. It returns a void pointer that is pointing to the first byte of the what? Allocated memory. Now this is where I told you, remember I told you that you need to have what? You need to have a prerequisite a knowledge in what? In pointers. Now when I say void pointers, you should understand what I mean by what? Void pointers. Can anybody tell us what a void pointer is? Anybody?
Okay, is a pointer that does not return any value.
Please come again.
A void pointer. Void pointer.
Okay, it is a pointer that does not have any return value. It returns value of, it does not have a return value. Let's put it that way.
Yeah. Oh, sorry, I was having my pen in my mouth. Okay, you said a void pointer does not what? Have a return value. Is someone typing sometimes? Hearing some room. Okay, no return value. Okay, all right.
Okay, so I also want to say something. We also say void pointer is a type of pointer that doesn't point to any known data type. It can just point to any generic data type.
Okay, yes. A void pointer doesn't have a data type. No, now when you a void pointer, okay, let me just explain. It's just like it said, it doesn't associate with any kind of what? Data type. Okay, now when you are doing this dynamic memory allocation, there's one thing you should know. Okay, that what, when you, this memory allocation that that is being assigned to a particular pointer, or let me just say a pointer or an array, okay, now these functions, they don't know the data type of what they are, they are allocating memory to. Okay, let me put it in that format. Okay, so this malloc function does not have any idea of what it is pointing to. Its own job is just to allocate memory. Its own job is just to allocate memory. It doesn't have any idea about what it is allocating the memory to. Okay, so it doesn't have idea about the data type of what it is being, what the memory, what the variable that is being what, or the pointer or anything that is being what. Probably when you do this memory allocation, we are talking about data structures there. When you hear data structure, you should know that you're dealing with pointers. And when you hear pointer, you are pointing what you, anything memory allocation, you are assigning a kind of memory address, okay? That's the address of a variable, of an array, or anything, any sort of things like that. So that is why the return value of malloc is a pointer, because what, malloc does not have any idea of what it is pointing to, what it is allocating the memory to. All it just want to do is just to what, to allocate memory. So let me just give you the syntax of malloc. Don't worry, this will be more clear when we start on doing some basic example on this. So we have the basic syntax of malloc goes as thus. Sorry. So we have the void pointer. So we have a void pointer, and just do it this way. Then followed by the function malloc. Then inside the parentheses, it take this this data type, that's the, I think they call it size underscore t, of what, of size. Don't let it, I will explain what each and every one of these means. So this is just the basic syntax that you see. Even though, let me open my terminal so that I will just put all these. Okay, I think I don't need you. Okay, sorry, let me just clear this one. So let me just so if I should run the manual for malloc, for instance, I'm going to have, this is it, this is what you get. This is just the syntax of what, of malloc. So he's returning what, a void pointer. This is either you write it like this or the way I've written it here. Okay, it still means the same thing. That means what, the return value of this malloc function is a void, what, is a void pointer, and that pointer is pointing to the first, is pointing to the first byte of the allocated memory. The first byte of the allocated memory. I will explain, I will show you what I mean by that in a minute. Just let me just define what this is. Now this data type, this is a data type. This size is just what, the size of what you are what. This is just to signify the size of what you want to what, allocate what memory to. Where size is the size of what you want to allocate memory to. So let's say, for instance, the size of the data type, rather, sorry about that, my bad. So now here, this size, this data type called what, size underscore t, I don't know what they call it, but it is referred to as, it is defined in this what, in this library as, it is defined as unsigned integers. Can someone tell me what unsigned integers are? Well, when I mean unsigned integer, what do I mean? Anybody? Somebody?
Integers
It has to be a positive value.
Yes. I like to call them a non-negative It's still the same thing when you just call it a value. I'm just trying to use this one. Don't mind my English. Non-negative what? Integers. That's what they mean by what? Unsigned integers. And that was what is being represented by this what? This data type size t. It is being defined inside this what library, probably as a macro, I don't know, but it actually means what? Unsigned what? Integers. So basically, like here, the size of what you are passing here can never be what? Negative. The size that you are passing inside this place, it can never be what? Negative. Now this data type is for this what? The size of what you want to, the size of what you want to allocate memory to. Okay, so it has to be what? Positive integers. It can never be negative. If you pass in a negative value here, you will enter into trouble. You don't want to enter into trouble, right? Now, when we say void pointer, like I've explained before, this malloc doesn't know what it is pointing to. This void pointer basically means what? It doesn't have any data type. It is not associated with any data type. So if it is not associated with any data type, that means what? We can typecast the pointer to the data type that we want. Okay, I'm going to give you an example on this. Probably before we go further, before I explain further, let's just take a quick example on how malloc works. Example on what? Malloc. So I'm just going to write a basic function, then I'm going to use that on a basic program, and I'm going to use that program to explain. Or let me just give you just a simple example here, just to illustrate this this syntax. So basically, if you have a pointer pointing to an array of integer, you are trying to assign you are trying to allocate memory to this pointer of an array. You know, pointers, when you declare a pointer, it is pointing to an address of something, an address of a variable. Okay, so now in this case, you pass in. Now we said this is going to be a void pointer, and we said a void pointer that is being returned here can be what? Can be typecasted. Okay, so how do you typecast it? By just passing what? Int, just changing this void pointer to an int pointer like this. That means what? You've typecasted the return value of what? This malloc to an int, because what? You have a what? You are assigning this address to what? An integer what? Pointer. So you need to typecast it to an int. So let me just write this. Let me just finish writing this, and you have, okay, sorry about that. Go back up. So we have this, and into brackets, probably, let me just use this what? Size of, just have what? Int. Let's say you have an array. Okay, when you have an array, how do you know? So, and this pointer is pointing to probably an array. Let me just have this. Okay, don't let me confuse you guys too much. Okay, now you have an array, for instance, and that is where what this pointer is pointing to. Now you want to allocate memory to that what? Array of what? Integers. That's why we're passing what? Size of what? Integers. So this is how you basically what? Allocate memory to an array or a pointer. Oh shit. So it was when I lost memory connection, I paused the recording. So so technically you can replace this by just saying 4. That means I'm just assuming I'm working on a 64-bit Abi, that's what you said, on a 64-bit system, operating system, on a 64-bit system. So what this means is what? Malloc will allocate what? 4 bytes of memory, which That means malloc will allocate 4 bytes of memory at the address of the first byte. It will allocate 4 bytes of memory to this what pointer, and the address of the first byte of I'm coming. I don't want to use a confusing English. Okay. I told you that word byte or malloc return a pointer to the first byte of the what? Of continue. So as I was saying, I told you that what this malloc functions returns a void pointer which is pointed to the first byte of the allocated memory. So let's assume we have what this is someone's mic is on. Please mute yourself. Please hold on. Okay. So now, what this simply means is what this malloc will allocate what 4 bytes of memory and it will return what an integer pointer. See, we have what I can't highlight it. Oh, sorry. It will return an integer pointer. No, this is not what I wanted to do. To see, sorry. It will return an where is that? Okay, yeah. It will return an integer pointer. Sorry, okay, yeah, this is what I wanted. So now malloc will allocate 4 bytes of memory to this they call it heap, in the heap or stack and heap. I'm going to, when we go into examples, you're going to understand better. Then it will return an integer pointer that is pointing to the what? To the first what? Byte. That is pointing to the first byte and store it inside what? This pointer PTR. You can decide to name this anything. Okay. Basically this is the what? This is the syntax of what? Of malloc. And that is what is being what? Represented here. So when this operation is being carried out, malloc will assign what? 4 bytes. And then this point, it will return a pointer, and we've typecasted the pointer to an integer pointer, which is pointing to the first what? Byte of what? Of this. Probably you are trying to assign this memory to an array. Like for instance, we are trying to what? Assign the memory to an array like this. Then okay, this is just allocating. We don't have, I'm not making reference to these values that we have here. Forget this. So I'm just trying to say, if we are assigning this memory to an array that is containing what? Series of elements. So this pointer that is being returned, it will be holding the address of the what? Of the first element inside the what? Inside the array. And that address is being stored inside this what? Inside this pointer called what? PTR. And that is the if the address is being stored inside this pointer, then we can what? We can find the remaining address of the what? Of the element inside the array. Let's say for instance, the first address that this thing is pointing to is probably let me just say, memory address is given in hexadecimal number figure or digits. Okay, if this, let me just use a normal random digit. Let's say this one, the address that this pointer returns, this malloc returns, is probably 2000. That means in that array, the first element in that array, we have the address of what? 2000. Then the next element, we have address of what? 2004. Because what? We have an int takes a size of what? 4 bytes. So for every 4 bytes, there is what? There is an element, there is an integer. Okay, don't worry, we are going to particularize all of this. So let's just go straight into an example, a user I'm going to do, I don't know what they call it, hard coding or soft coding, but I'm going to make it user interactive. I'm going to ask the user for the number of integers that the user wants in the array. Then I'm going to ask the user to what? To enter the integers that that array is going to to specify. So basically what I mean is I'm going to write a program that asks the user for what? The numbers, or probably a user wants to like add some certain range of numbers. Okay, I'm going to ask the user to give me the total number of the total size of the total size of the integers. That's the how many integers you want to add. Probably the user wants to add like 5 integers, for instance. Then I'm going to ask the user to enter those 5 integers. Then I will perform my program is going to perform the operation for me, for the user. Okay, but inside the program I'm going to dynamically allocate memory to what the user is giving us. Okay, let's go right into it. Probably I'm going to use that one to explain better. I hope I'm not confusing anybody here. I just sincerely hope I'm not confusing anybody. Please don't get confused, okay?
I'm confused though.
Don't get confused yet. 9. Don't get confused yet. So I'm just going to wait, let me do this. What is it? Okay. I'm just going to make a directory inside here. Call it memory allocation. Then I'm going to cd memory allocation, and I'm going to let me just call this malloc.c. Okay, since we are going to assigning memory to this, so I want to write a simple program, okay, that is going to let me just write what I want to write here. Okay, I've already. Okay, so write a program, or probably don't let me use on sum. Let me just print out, write a program that I will give you the sum as an assignment. Write a program that prints out the number. I want to properly construct this. Write a program that adds write a program that sorry about this wasting of time, that asks users for numbers to be printed out. Let me just put it like this, but you understand when I start. Okay, since I'm going to be getting, and I want to it's always a good idea to allocate memory to your array. Okay, you need to always allocate memory, and we already explained why the static memory allocation is not really advisable. We need to go for the dynamic memory allocation approach. Okay, and I explained all of that. That's using the built-in function that is being defined inside the standard header file called std library. So now I'm going to first include, since I'm going to be printing, I'm going to be including my standard input and output header file. Then since I'm going to be dynamically allocating memory using malloc, then I'm going to be including this library as well, stdlib.h. Okay, now I'm I'm going to be writing this thing inside the main function, which is going to have a void parameter. Yeah, and this I'm going to have my return value down, so I won't forget to add this. Okay, so now let's go right into it. Now, before we go further, okay, now let's do a little experiment. Nums, now you are dealing with numbers, but you are dealing with numbers, a set of numbers, that's an array. Okay, on the nums you are going to be having something like this, then passing this. Okay, and just do this. You have this, passing this, then you have this to be equal to some kind of numbers. This is just the basic syntax of an array, but this time I'm having an array of integers. Okay, now you are going to passing a certain number here. That means what you are doing, a kind of static memory allocation here, that your the element that can be inside this array must be 4. You can't have more than 4. Okay, you can't have more than 4, and I explain why. If you have less than 4, you are going to be wasting the memory that you allocated to this array. But if the user passing more than 4 elements inside here, your program is going to crash or misbehave. You are going to get some kind of error, or probably you are trying to set a value to a memory that is not being allocated to you. I think that's where you get segmentation fault in some cases. Let me put up this fan for a minute. It's getting too much. Okay, so now, and the way to solve this is to use the dynamic memory allocation approach. Okay, now for this one, I'm going to be declaring the variables I need, and the variables I need is I'm going to be needing the index, since I want to print the numbers of the numbers that is being passed in by the user, definitely, and is that number is going to be stored inside an array. Okay, and the way we can store that value is using a pointer. Okay, so that we can use the pointer to point to the address of the first element inside a particular array. So let me just go like this. Then I'm going to need n, which is represent the size of the array. Then I'm going to ask the user to print, okay, let me just say enter the number of integers. Okay, enter the number of integers you want to print. Let me just this thing is just okay. Enter the numbers of integers you want to print. That means this one is standing for Can someone guess what these numbers of this number of integers, which of these
The number of elements you want to enter into the array.
No, yes, exactly. That's n. That's what I'm signifying as my n. So I'm going to be using scanf to help me to get this data and save it inside the address of n. Okay, so I'm going to
D in that your
okay, sorry. So we have %d, then followed by address of n. Okay, so that means this scanf is going to locate the address of this variable and store the value that the user inputted for us here as the numbers of integers that the user wants to print. Okay, I think I made a mistake here, okay, that the user wants to print. Okay, I hope this is clear. So now, after the user have entered the numbers that he wants to print, now we need to allocate memory to that to the array. Okay, let me just do this. So I'm having a pointer. Okay, I'm storing this address somewhere. I'm going to have, I'm using the syntax I wrote earlier here, this syntax that I wrote here. Okay, so I'm typecasting this already, because what I'm expecting what integer from the user. Then I'm going to use the malloc to allocate memory. Now, what is the size? Like I said, when I was, this is not just a single integer. These are series of integers. That's where this n comes in place. Now we need to to tell malloc that you want a particular size of integer based on your your operating system. You need to specify what data type are you collecting from the user, which is size of integer, and how many integers are there that the user wants to be inside this array is going to be multiplied by by n. I hope this is making sense. Now I'm telling malloc to allocate a particular size of a particular byte, and the integers are they are. We don't know the numbers of integers. They are n total number of integers. If this is 1, it's going to just allocate a size of for that just one integer, and return a pointer that is pointing to that one integer, and save it inside inside this guy that is here. Okay, that means this guy is having the address of the first integer that is being passed by the by the user. I hope it's making sense bit by bit. So now there's you need to always check. You need to always check. Now, what if the user does not pass in any value? For instance, what if the user passing 0 as the size of as the number of integers that the user wants to add? 0 is null. Okay, that is where you need to always check. Use the null pointer. Null is also a pointer which signifies 0. It doesn't have there's no how will I say this? It's always advisable to use null instead of they use null pointer to check if a memory is being allocated to a particular pointer or not. Okay, if the malloc function, the malloc is used to allocate memory, so the null pointer is always used to check if there is a size. Okay, so let me just go on. So we have if pointer. Okay, that's this guy. This guy is holding if the address. Now what is stored inside pointer is address of that is being allocated, this memory this memory address that is gotten from this allocation. Okay, if this pointer is equal to is equal to null. Okay, what do you want to do? You want to do something. Okay, sorry about this. You want to print. That means in this case no memory allocation was actually done. You want to print memory memory was not allocated. Okay, then you might probably they always do something. You can exit out of the function. You can use this exit function with a status code, and once this is like a status code of where there's no memory allocation, is always 1, a status code of 1, which means this is a failure, it's not a success. That means on failure, it should print this memory was not allocated, then it should exit out of the program with a status code of 1. Okay, else what if the memory was allocated? That is when we want to print individual values of what the user passed in. Here we just ask the user to enter some certain numbers. Okay, so I'm just going to do something before I actually ask the user to input those what numbers that he wants to print. Okay, let me just use printf. So if this was successful, you should have something like, okay, memory, this is just memory was successfully allocated. Okay, afterwards you want to probably now can someone tell me how we can get the number? Okay, we want to ask the user is probably going to enter some certain, what if the user like enter 5, for instance. We can't keep having printf, like we can't be having printf 5 times. We can't just ask the user to like enter 5 integers. Or what if the user enter more than 5, then press enter? Okay, so in this case we are going to use a loop to access what the position of each element in the array. You know, this is what the size of the integer what array. So let me just finish writing this, then I'm going to explain. So I'm going to use a for loop. So I'm going to say for I is equal to 0, which this is from the first from this first element. Then I will have to be what? To be less than, you know, definitely the index is always what? N minus 1, the size of the array minus 1. Okay, that's the total index is always what? 1 less than what? The size of the array. So N less than, that's if you're starting from 0. So but basically we start from is always advisable to start from 0. So N less than 1, I less than N, then we want to keep what? Incrementing I plus plus. So in this case, what do we want to do here? So for each number of time, we want to keep asking the user to enter, let me just say, so enter an integer. In this case, that means what? This question will keep popping up as long as depending on the number of integers that the user said he wants to print. If the user say he wants to print like 5 integers, this printf is going to occur what? 5 times. Do you understand why the reason why I use a loop here? I don't want to like there's no way you can, this can f, I don't know, it can only save one value at a time. You can't keep using multiple printfs, and one printf enter the first integer, enter the second integer, enter that's going to probably, instead of that, I just want to use a loop to help me to fetch the numbers that is being entered by the user. So I'm just going to ask the user to enter the integer. So this is going to be prompted out 5 times. That's if the user enter 5 numbers of integers to be printed. It's going to ask the user 3 times if the user enter 3 numbers to be printed. So for those 3 times, I want to get those numbers and store it inside where. This is now where I'm going to now where am I storing the numbers that is being entered here? Now remember, this pointer that is here, this pointer is pointing to the address of what? Of the first is pointing to the address of the first byte of the allocated memory. Okay, if the memory was being allocated to 5 integers, that means what? This pointer is pointing to the what? To the first integer. Are we clear? Hello, are you guys with me?
Yeah, we're together.
You're together. Okay. So let me just do something here practically before I actually write this, because it's something you've done in pointer. I want to use something here. So let me just do something like this. So I'm just going to do this. Let me just have another comment here. So now what I mean, what's the problem? Sorry. So what I mean here is this PTR, if you have an array, for instance, if you have an array, let me just say this, an array of 3 integers, for instance, and I'm going to say this is equal to, sorry about that, this is equal to, we have 1, 2, 3, for instance, and you have a pointer that is pointing to the address of, do you know that this, if you have a pointer that is pointing to this array, the pointer itself is going to have the address, the address of value 1. That's what I mean by what the pointer is going to point to, the first byte of the allocated memory. That means this is the I'm using this static memory allocation to explain something here, so that you will see the beauty of what I actually want to put in as what the address of where this integer that is being passed is going to be stored. Okay, now if I say that this is we are allocating to 3 elements. Okay, and the value, this pointer is going to be pointing to the address of of the first byte, address of, let me write it up, address of the first byte of the allocated memory. Okay, and the first byte of the allocated memory is having a value of, of 1. Okay, now for each of these integers, this is going to occupy 4 bytes, this one is going to occupy another 4 bytes, this one is going to occupy another 4 bytes. That's if you are working on a 64-bit OS. Okay, now because we have 3 of them, that means the pointer that will be pointing to this array will be will be pointing to the address of the first one. So if you now want to get the value of the second one using a pointer, is going to be that pointer arithmetic. You are going to dereference the pointer and add it to 1. You first add that pointer to 1. That means this pointer is at this at the first, this is the first byte of the allocated memory. That means this is the first, this is the second, and this is the third, because we have we allocated 3 to it. That means basically the total byte of this will be 3 times 4, which is 12. So if this address is is 2000, like I said before, the address of this second value will be 2004, and the address of this third value will be 2008. Do you get what I'm saying here? Well, I hope that is clear. So from that knowledge, so how am I going to use scanf to store the value? That means I need to store this value in the address of the first one. We have the address, since I'm starting from 0, and 0 is the first value. The 0 is the index position of the of the first element in whatever array that we have. Okay, so I'm just going to use ptr, sorry, since ptr plus I, let me just put this in brackets so it to be clear for everybody. Do you guys understand this? ptr plus I, because what scanf takes what address of, and this one we don't need to put ampersand here, because what this pointer means what is storing what the address of what of this array, of the array that we want to what we allocated the size to. Okay, you know, normal when you say a pointer, this is how you declare a pointer. Like I hope I'm not talking to myself right now. This is how you declare a pointer. And pointer, okay, you declare a pointer like this. Then if you want to assign the address of it, you do what pointer is equal to what address of a particular what variable. Let me just say array, but this is not actually, let me just say variable. Okay, address of a particular variable. Okay, this is it. So this, we don't need to put ampersand here, because what this pointer means what address of a particular is, it means what address of a particular variable, be it a variable or an array. That's why I have it here. And this I is signifying that, okay, since I'm starting from 0 and I'm using a for loop here, that means what this is going to be shifting as long as, so for the first one, ptr plus 0 will just be what ptr, which is what, which is going to be pointing to the first byte of what, which is going to be just normal ptr, which is going to be pointing to the what, to the address of the first byte of the allocated what memory. I hope this is clear. So for the next value, like now, if this value is 3, for instance, the first time is going to be just what ptr. The second time is going to be what ptr plus 1. That means it's going to shift position to the next what, to the next element, to the next address. It's going to store that value in the what, in the next address, and the next address will be what, will be stored with the value that is entered by the user from here. And it will keep going, it will keep going. That's why I have this what, this expression here, because I'm using what, a for loop. Are we on the same page? Hello?
Yes, please.
Okay.
Yes, sir.
So now, after getting the value and I've stored it in a pointer, that in an array with the help of this word pointer, I want to print those values. I've stored them in a particular what location inside my computer. So I want to print out those values using what, using pointer, using the pointer. You know, when you want to print a value with the help of pointer, you need to dereference the pointer so that you can print the value that is being stored inside that what, that the address that is stored inside the pointer is holding. Don't get it twisted. A pointer stores address of a variable. Okay, but if you want to print the value that that variable is holding, you need to what, to dereference. And dereferencing means you just need to what, to attach what, an asterisk to it. That means you want to print the value stored at that address. Okay, so with that, since I want to print each of these values, I'm going to use what, another loop to help me to print each of the values. So now I'm going to use another for loop. This loop is just helping me to get what, the integers from the user. Then this other loop is now what I'm not doing the question. I want to print out those what, those numbers that the what, that the user what inputted in my program. So I'm going to use another for loop using the same, starting from the very first one. Okay, from the very first index to the last index, which is what, n minus 1. That's why I'm having what, I is less than n. Then I want to what, to keep what, updating the value of I so that I can keep what, incrementing, so I won't run into an infinite loop. So what do I want to do here? I want to, let me just say, I want to print the numbers using what, the pointer. So I'm going to do this. let me just say percent. So let me just print the numbers on a straight line. So percent D, then let me use a space. Let me use a space to differentiate the numbers. Okay, I don't want to print them on a straight line. Now, how will I print the values? Because now I'm using percent D. Do you know what? Let's do this. Let's print the address and the value. Okay, so I want to print the address of each one of them. So print F. Let me do so what's the specifier to print address?
Percentage P.
Okay, percent P. Okay, address value. Okay. Do you know what? Don't let me use 2printf. Let me just use 1. Then I'll print the address and the value of that of that particular at that particular index position. So let me just say address. Is this how to spell address? Sorry. Address is percent P. I hope you guys understand what I'm doing here. And value is percent D, so that the first one will be what? The first one will be what? Address of the of that variable, of that value, where that value is being stored. Okay, so we need what? We need two arguments here. The first one is going to be standing for the address at that particular position. So the address is to just be what? Pointer ptr plus I. Okay, then the value, this is where I came about. This is where I talked about what you dereferencing. You know, this one is just what? Address. This pointer means what? Address. You know, we do not dereference. That's exactly what I used in this scanf. So the address at each at each index. Okay, that is what this means. Then I'm going to use a dereferencing here to print what? The pointer, sorry, the value at that pointer of each of each index. I think I saw you guys doing something like this. So these two shouldn't be new to you guys. These two things shouldn't be new to you guys. I think I saw something yesterday. Do you know that what I wrote here is different from I'm going to write something now. There's a cockroach disturbing me here. Okay, I will come and kill you later. Don't have your time yet. What I wrote here is different from this. PTR plus 1 is not equal to, is not equal to sorry, let me just use this one. Don't let me confuse you guys. It's not equal to this PT. Do you know that? I think for those that were here probably yesterday, I think it was yesterday you did this now. You already find out that what this is different from from this. You know, normal when you are dealing with this is going to go by precision. So the bracket, what is inside the bracket will first get executed before going outside the bracket. But this one is different. This one is saying that this one is just pointing to the value at the first array. Let's take this array for instance. The pointer, the referencing this value. If you look at this array, if you are taking this array as a case study, their value means 1. What you will get as an output from here will be 1 plus 1. But for this one, what we will get as a value is this one will first point to the to the next address, and then Now what? Dereference that one. That means the value we are going to be getting here will be what? Will be 2. Okay, will still be 1 plus 1 will be 2, but let me just change this value so that it won't be, I don't want it to be this. Let me just have 5, and this one will be 4. 5, 4, 3. Okay, for this one, it means what? We want to do, this is I think this our boss lady called this what? Arithmetic or pointer operation. Arithmetic operations on pointers. Okay, so now you are adding the value of the first what? Of the first address to 1. But here you are pointing to the second address and printing the what? The value with this what? The referencing operator. Do you get the difference between this and what? And this? And definitely this is not equal to this. You know, I told you what? This is just what? The address of a particular, let's say I is 0 now. This one will be what? The pointer, that the address plus 0, which is what? That pointer. And that is what is being printed, will be printed with this. Then followed by what? The address, followed by what? This one means what? The address of the what? Of 0, which is the first one. Then what? With this dereferencing, we now print the what? The value at this what? At this what? Address. I'm writing and I'm explaining. I don't want to write everything fully before I start explaining. Hello? Anybody home? Okay.
Yeah.
Okay.
Yes.
Okay, thank you very much. So I want to differentiate these guys. Let me just print a new line here so it will not be jam-packed. Okay, so okay, do someone want to talk? Who is okay, probably hello Gambia. Any issue? Oh, your system is always low, Ezekiel. I think you have already left. Anyway, so I did not see that. So before we check the output, okay, add a new line on line 20. I think that was what I just did now. On line 20, where is line 20? Oh, I've scattered everything up. Okay, I think you meant here. Let me just add a new line here. So it will not be, this will not be what? Will not be merged with this printf. You know, this one will be printed first. Without the new line, this one will just follow it here. So that's why I'm having that new line there. So any questions so far concerning this? So regardless of whatever the user what say, that whatever element or value or data that the user want to what input, this malloc will assign a memory to that what, to those values. Okay, to the full array, and return the what, the pointer to the first one, so that we can access the remaining ones. You know, if you don't have the first one, there's no way you can access the remaining one inside the array. If you don't have a way to get the address of the first one, there's no way you can access the address of the next one, and of the next one, and of the following one. If this were just to be returning the address of the whole total array, there's no way you can specify which one is the first one or which one is the second one. So that's why the pointer is always, what is being returned by the malloc is always the pointer to the first byte of the allocated memory. And where you use malloc is where you have what, data structures like arrays, or you have let me just say basically arrays. You have arrays of integers or characters, or you have a string, and so on and so forth. Any questions so far as what this example is concerned?
Yes.
Okay.
So I have 3 questions.
Yeah.
On exactly line 12.
Line 12. Where is it? Okay. Yeah.
So, can we decide to our integer pointer that we declared? Can we decide to declare it maybe on line 11? Then later we'll now say our PTR equals to that. Will it still work?
Yeah.
Then
It will work.
question
Yeah, I'm declaring and assigning. Yeah.
at the same time.
So this will also work. Okay, don't mind the way I actually like declaring and what and assigning. So let me just declare my pointer here. Don't let me quash it with this one. Don't let me confuse people here. Let me just declare the pointer here. You know, like I said, this is how you declare a pointer. So I'm using the pointer to store the address. You know, this one is going to return an address. Malloc will always return an address, but the address is returning will be stored inside a void pointer that is pointing to the first byte of the what allocated memory. First byte of the allocated memory in the sense of if the memory that is being allocated, you are allocating memory to some certain set of numbers, like in our own case, for instance, now we don't know what the user will input. Okay, we don't know what the user is input. That's why we are using a variable to store what the numbers of what of the array, just like we have here. We are using, instead of us passing it inside our program like this and avoiding our program to crash by where the user will input more than what we specified. That means if the user was to enter 3 and get and actually pass this, so we are using the n, which is 3, to what to allocate a memory for it based on what the data type of what of that what of the size. And mind you, I make mention of what malloc doesn't know what. You can see this one is just size. Definitely we need to know the what the is this one will always be size of it. Malloc doesn't know the address of the value of what will be inside what this thing. The only thing he knows what is the size of what he wants to allocate memory to. It doesn't know the data type of what is pointing to. That's why it is being returned a void pointer, and we are already we already typecasted it here, because what we are having the pointer, this pointer is an integer pointer. If this were to be character pointer, like for instance a character pointer, that's an array character for instance, or a string, you know it's going to be a character pointer, then we are going to be typecasting this with a with a character pointer, so that the void pointer will be turned to a character pointer, and I will be holding the address of the first character in the in the array. Is that clear? Next question. So we can definitely do this. We can declare it here, then assign value to the value we are assigning is is the address that is being returned from here. Okay.
Thank you very much.
Yeah.
Hello.
Yes.
Oh, sorry, I just want to ask. You mentioned now that this malloc function is to return address, a void pointer, right?
Is going to return a void pointer pointing to the address of the first byte of the allocated memory. That English is very large, but
So if you're saying, sorry, let me ask so that you understand me.
yeah,
So if
answer
you're
question.
saying it's returning to a void pointer, that means shouldn't line 9 be void, then pointer, instead of saying int?
No, this is, we want to store this address inside a pointer, an integer pointer, because we want this we are getting an array of integers from the user. So this pointer is going to help us. The reason why I have integer here is because what I'm going to have an array of what integers from the user. This is not the return of what of the malloc. The return of the malloc is this thing. I typecasted this. Now this one is going to operate. It's going to have a value. The value that we are going to get from here is an address of the first byte of the allocated memory, and that address I'm storing it inside a pointer. Okay, because what is only a pointer that can store an address. Are you getting me? And that
Yes,
address
yes.
have been typecasted to an integer because what I declared was an integer. We having void there, it doesn't. Have you seen a void pointer doesn't have a data type? You definitely need to typecast your void pointer depending on what the data you are working with. I'm working with integer data. That's why I have an integer here. If I was actually working with, probably I ask the user to print probably alphabet. I want the user to print on some certain alphabet, probably from somewhere to somewhere, or probably, I don't know, a particular string or something. Then that case will have been different. Instead of having int, I'm going to be having car. Did you get that?
Yes, yes. Thank you very much.
Yeah. Question. Come on. Don't worry, we still need to talk about free, even though we'll talk about free in just short minutes after doing all of this. The free function is not something buoyant like that. Any other question? I thought someone said he has 3 questions. You only asked 1.
Okay, yes. You've answered some actually, but our line 13, can we change where we have inside our malloc function, we have the size of int then times our hen? I think we can also take it because I've seen programs like that. Their hen, that is the size, will come first, followed by their size of int. Is that still acceptable?
You want n to come first, then the size of int should be last.
Yes.
That will be n times size of int.
Yes, something
It's
like
still
that.
the same thing now. 2 times 3 is 6. 3 times 2 is 6. Whichever way you multiply, you are still going to get the same value. Okay? Because
Then
this is going to be an unsigned value, because this is also an unsigned value as well.
Okay. If we are taking off the typecasting on line 13, that our integer asterisk, that is the integer pointer, if we are taking it off, if we have called only malloc size of to the end like that, that means our line 9 would have been void asterisk ptr instead of the 8 that we put there. So our integer asterisk is the one actually changing the void to int, but we are taking it off, automatically malloc will always store it in a void pointer.
Yes, you're correct. They just brought the light, so my network might go off in some minute because they want to change over. So, and okay, the guy has gone to change over self. So just give me 1 minute from now, because my Wi-Fi takes a minute before it loads back. Okay, so with that, be thinking of a question that you want to ask. So does anyone else have a question? So,
don't lie, I'm still struggling to understand this concept.
You're still struggling to understand the concept. Where exactly?
No, the thing is this. I understand the logic and everything you said, but I feel after After 30 minutes like this, everything will scatter.
I think Emmanuel, do you have something?
Yes, sir. I'm feeling the same way.
But you understand what I just wrote back?
Yes. No, your explanation does. You don't have any issue on your explanation. Possibly it will require a repetition. So I don't want to budge because there are some persons understanding. So strength differs. So that they have it. So no, it's
No
just
worry.
for if
Wait.
there's repetition. Mm.
Okay. Um. Okay. Don't know. Okay. Nobody else is raising up his hand. So okay. Wow. What's happening? Probably is because of the example I used. But basically, you understand the theoretical explanation I gave on malloc. Okay. And why malloc is returning a void pointer, because what let me go back to this board. You guys should take it. Maybe so. If you solve more examples, you will understand. Trust me. The more example you solve, you will understand. What you're just using here is just using malloc to what? To assign what? Memory to a particular what? To a particular data or datas. Okay, that means you want to store some datas inside your computer or inside memory. You need to allocate some certain memory. So now, and I say that what malloc does not have any idea what it is pointing to. All it just have to do is just to assign or allocate memory requested by, most time requested by the user. The most cases where you use malloc is where you are, when the user is trying to like enter some certain set of datas, okay, like in terms of array, okay, or you are trying to get, or probably the data your user is trying to store a particular string inside an array. You need to know the size of that string that the user is passing into the array, then allocate memory specifically to it, so that you won't have memory wastage or lack of memory. Because this dynamic memory allocation is just allocating memory at the time of what? Execution. During execution is where the memory will be allocated. The memory is not being allocated by the what? By the programmer. Okay, so let's go back to this. And I told you that what is returning what? A void pointer. Okay, that's why, because what malloc doesn't know anything about what is being the type of data that is being stored inside that memory that was allocated. That's why we are actually having it to return a void pointer. And the reason why we typecasted this to an integer, because what we are having the type of data that the user is is that we are assigning, we are allocating memory to, is what is an integer. That's why we are typecasting the address. We are typecasting the void pointer that holds the address of this to what? To an integer, so that we can store it inside what? An integer, the integer pointer that we have here. So it will point to the first byte of memory that was allocated in the array. Let me just put it like that. Okay, it's not that difficult, it's not that hard. Okay, with more examples, you'll be open to so many things. So don't get this one is just one of many examples that we have out there. There are so many examples that you can do this. Okay, so let me just run this program and see if our program is running as intended. So now this program is basically going to ask, first thing is going to ask the user to enter the number of integers that the user wants to print. Then afterwards, this is going to perform its operation as allocate memory to that of particular numbers of integers with the malloc function. Okay, then like now, let's say for instance we pass in 0, then your pointer will be I think this should return this. If the pointer is null, that means the memory wasn't able to allocate. You only allocate memory to something visible. You can't allocate memory to a 0 because it won't be taking any space in the, if you are signifying that the size of your array is 0 now, for instance, that means you don't have any element, it is empty. So definitely you can't assign memory to it. So the memory, they call it dangling. That address, the pointer will be dangling. It will just be there. That address is not existing. But okay. So probably when we take on more questions, probably in our next section, we'll take on questions from the intranet and try to solve 1 or 2 or 3 questions. Then maybe you will understand better there. And if, I don't know if Topman will be able to take this section again, all over again, but I don't know what else to say. So can let's just run our program and see if it is working as intended. In this case, we are going to be getting, okay, let me just escape, save this. So if I should compile, let me send the file into malloc. Okay, it's compiled without an error. That means there was no error in the code during execution, during the compilation time. So let's execute the file. So it asks, enter the number of integers you want to print. Okay, so I'm going to, someone should give me a number. How many integers you want to print? Somebody?
5.
5. Okay, then now you can see the reason why. I remember when I was explaining that time that the user, if you are doing a static memory allocation and you are asking the user to enter, you've already allocated the memory inside, like I said, from here now. I was saying like here, for instance, you've already allocated the memory inside your program, and you are now asking the user to enter the number of you told the user specifically inside here that please enter 3 integers. But in the process of entering the integers, the user now enter 2. Like for instance, you can see I'm able to enter like 5 space 6. Definitely what this is expecting is just one single value. Okay, but it happens like that. In that case, we are going to run into some kind of difficulty, some kind of errors. Your program might crash. So now you are telling the user to, okay, enter the numbers of integers you want to print. Okay, I want to print 5 integers. Okay, good. So okay, it said what? Memory was successfully allocated. So now the next thing is to what? Enter an integer. That means this thing is going to be populated 5 times because of the loop that we used. Okay, so what's the first integer? Let's go. Somebody give me an integer.
3.
3. Okay. An integer.
7.
7. Another one. Yeah.
6.
10.
10. Okay. Thank you. Another one.
Like lens.
Eh?
So
Integer. Oh. Is it too hard to give an integer?
12.
12. Okay. I think it remains one more.
94.
94.
Let's put negative
Aha.
and -5.
You can see we have what? We have the address is this guy. And then the value is this guy. Okay. You can see this is 0. Then the next one is what? 4. That means my system is the size of an int inside my system is what? Is 4 bytes. Okay. Then the next one is 8. This should be 12 because this thing is actually printing in hexadecimal number. And I think hexadecimal numbers, which is just the last happy. Yeah. I don't know how this goes, but this value that you have here should be 12. Then this should be 16. Yeah. So you can see how the memory was being allocated for each one of them. And you can see that what the void pointer that was being returned by malloc is this guy, is this one that we saved inside the what? Inside that what? Integer pointer that we declared. So this is the pointer that was being returned by malloc. It's because of this first one that we're able to what? Have access to the what? To the remaining what? To the remaining ones. Do you get what is happening here?
So come again.
You can say it comes from that. It initiated the counts on the addresses.
Okay. Let me just.
Okay. I get what you're saying now from the
Yeah. Let me
address.
just malloc. Let's see. This is going to. Like this line 10 now. The address. You know, I told you that what malloc will return a void pointer, and we've already forget this typecasting for now. Okay, forget this typecasting for now. This malloc where I highlighted is going to what? Return a void pointer, and that void pointer is going to be pointing to the first address of the what? Of the allocated memory, and that first address that this one is pointing, this pointer that is being returned by malloc is pointing to is this one. If okay, let's just try it out. I'm going to do something for us here. vi malloc.c. So I'm just going to let me print this pointer first. Okay, let me print the address here. So you will see printf. I think someone is raising up his hand. Please help me to, who is that person? If you have a question, first. Okay. First address is since it's address I want to print, so I'm just going to print D. Let me follow it by a new line so it won't affect the other printing that is there. So I'm just going to, what am I printing, which is this guy, PTR. But that is where this is the pointer variable that we stored the address that is being returned by malloc. Okay, see what happens here. So let me clear my screen again. So I'm going to compile this again. It compiles without an error. And I'm going to execute the file. So it said enter the number of integers. How many integers this time around?
3, 3. That's
Okay,
not
3.
right.
You can see it has printed what? The first address for us. Now let's enter the 3 integers. Oh yeah?
5,
5.
5,
Okay, yes.
7,
7.
10.
9,
10.
9, 9.
Yeah, I'll go with the 10.
Shit.
So you can see that what this address, the first one, is the same thing as this guy. Can you see what is going on here? That has already cleared your doubt that what? That malloc will return what? A void point, a pointer pointing to the what? The first address in what? In the memory allocated. These are all the memories that was allocated by the pointer, but what? It can only return one of it, and which is what? Which is the first address. Are we good?
We can stop that. So the number 5 now, the 5 integer, number 5 integer we have there now is one. It's the address is one with the main function address. Yeah, the number 5. Okay, yeah, okay. From the previous one, you actually
Yeah, this is the
displayed there.
previous one.
Okay, no, I mean just
Which ones? Hello.
before this. You just 3 now. It's one with Okay, good.
Okay.
Okay. Here is it. Okay, this 5 now is one with the main pointer address. So the pointer address is now one with the integer.
This is the address that
The
was
first
being
integer.
returned by the what? By the malloc. Yes. And that's why we are able to what?
Okay.
To access the remaining what? The remaining addresses and assign value to them. That's why if you check the code, that's why we use the loop to what? To store the what? The integers into what? Each
Integer.
because what this pointer is having what? The first value. Then we can access the what? The remaining what? Addresses. You know, now this pointer will be first value for everyone. For I is equal to 0, which is the first one, which is just pointer. So if you do pointer plus 1, it will point to the next value. It will just jump to the next value. That's why we have that's why we have 4 here. And the next value will be what? 8. Because what size of an integer is what? Is 4 bytes.
4 bytes. Okay.
You get it now. That's why I was using an example of if the first value is 2000, then we can use that 2000 to get the remaining value by just what? Adding 4 to it.
4.
Yes. But if it were a character, if it were characters we're printing, it will have been 1, 2, 3, 4, and so on.
3, 4. Yeah, it's one in difference.
Yeah. Is it clear now? Okay.
Yes, sir.
Okay.
Yes, sir.
Now well done. We are all enjoying this boss. Boss man, I greet you, I salute you. So
You're doing well, sir.
Yes. So right about now, I'm supposed to have ended this section because I'm coming. Let me check. Oh, this guy have not yet messaged myself. Oh. Please hold on a minute. Okay. So let's go back into our function. Okay, and talk about free. Now, okay, inside our program, rather, I keep saying function. So so I'm going to skip alloc and realloc for now. Then talk about, I'm just going to, so that I won't bombard your brain with, go and digest this one now. So you just be, but this thing, the what's it called? The calloc and the realloc. Calloc works similarly to malloc. Then realloc is, from the name, is reallocation. That means we want to further allocate what memory to particular what to a particular data that you want to store. Then you need it, but don't worry, don't let us talk about that one for now. So let me just talk about the free function. Okay, the free functions. Now, do you know that this pointer that we store the address of a particular of what is being returned by the malloc? Do you know that this pointer will forever hold that address, even though we are actually done with, we are already done with what? We are already done with the word, with the program. Will forever remain there unless we what? We release the what? The memory. And releasing of that memory is what we refer to as what? Deallocation. We want to dealloc. That's where what? Free comes in. That's where free comes in. So the free function is used to release the dynamically allocated memory. Like any memory we will allocate dynamically using malloc, calloc, or realloc can be released. That means we are done with it. Can be released using what? The free function. Let me go back to this guy here. So using this what? This free function. And this okay, what's your problem? So yeah, this free function, it is just referred to, it is used to release the dynamically, sorry about the big grammar, dynamically allocated memory. That's all. And it has a syntax as well. The syntax is just this. Okay, this is just the syntax. This doesn't return anything. The return value is void. Unlike malloc and the realloc and the calloc, they all return a void pointer. But for this free function, it doesn't have a return value. The return is void. Okay, so it is like this, void, then call the function and passing the pointer as an argument. Okay, the pointer that is storing what? The address of what is being returned by what? By malloc. This is just the pointer, and this is how you free what? Memory. And now this memory doesn't free up automatically. We need to manually, it's the responsibility of the programmer to manually what? Free the memory after it has been used. Like now in this my program, I know certainly that after all of this process, this program will keep, after this program has ended, there is a need for me to what? To free the what? The memory, so that I can what? I can make the memory available for another what? Use, or for another purpose. I don't know, is someone raising up his hand? Okay, no, there's a question. Oh, you guys should stop distracting me. Anyways, so that is that. So basically that's just the, and it is always after all your program, just before the return, that is where you free the what? You release the memory that is being what? Allocated by whether malloc or calloc or whichever one. All you just need to do is to just, oh, this guy has already messaged me. All you just need to do here, you know, this one is a comment. Let me just tweet out the comment. Okay, just before the return, that's after your program has finished running, you just need to call the what? The free function, then passing what? The pointer into it. Then this is going to free the pointer. It's going to release the memory. Now, there's something you should take note of. I think I forgot to mention something. Please give me a minute. No, I dropped it there now. Yes. Yeah, sorry about that. Now, there's something you should take note of. Even after freeing the what? Even after deallocating, let me just use that word. Even after deallocating, do you know that your pointer will still be pointing to that what? To that memory, but the memory does not exist anymore. You know, when you use this free function, you are just trying to say that what, that memory is gone. It is not, it doesn't exist. But technically, you just freeing it doesn't mean that the pointer will still be pointing, we still have the address of that memory location. It's just like you saying oh, how should I say it? I want to use one layman explanation to actually explain what I mean by the address will still be holding the memory.
Can I try?
Okay, I'm coming. I'm trying to think, but just say what you want to say. Talk.
Okay, I wanted to use this example. Say, for instance, you have some money in the bank,
Yeah.
right? And then perhaps decide to withdraw an amount from it. Now, by record, you have withdrawn some money from it. Usually, you used to have that money. You will not be able to have. The only thing you will have access to is a record that that money was withdrawn if a statement is shown. I don't know if you got that.
I'm not totally sure if I got that, but let me just say the technical part of it. Like I said, even after freeing the memory, you still need to, the pointer will still be pointing to that what? That address. But that address doesn't exist. It's just like saying I don't want to use this example. It's a very, I think it is, they call it dangling pointer. The pointer will just be dangling. It is occupying it has an address, but you cannot find it. Like, I don't know, I've not actually put this to a test, but it is always a good practice to assign the pointer to a null, to 0, to a null pointer, so that it won't hold any address anymore. So let me just, I don't know if I print the value of, okay, let me just do this just to clarify what I'm saying. I've not actually done this. I just read it. I've not. Let me just say address after the allocating is %p. And I'm going to call PTL. Okay. Let me just put a new one here. So I think this is going to explain this, and I hope then if that idea is not wrong, just do this. So I'm just going to compile again. It's compiled without an error, and I'm going to execute. So let's say we want to print two numbers. So enter the first one, let me just say 4, enter the second one 5. Aha, you can see that what address after deallocating, it is still what? It is still this guy. But that this address doesn't exist anymore, but it is still pointing to it. It is still holding the address, but it doesn't exist anymore inside your how do I say it? It doesn't is I think it doesn't exist anymore. So it's always a good
The address is there, but it's no longer holding any data.
the address is there, but yeah, the address is there, but
Should I
you
help you?
can't. Yeah, help me out. I'm still
It's
looking
very
for that
easy. It's just
part of
like
what.
saying that a house is in an area now. The address to that house is there, but the house is no more there. If you
Okay,
get that explanation.
just like
Yes.
a house now, you've demolished the house, but you are still using the address of the house, but the house is no longer there. I think that one solved the whole issue. So for you to clear out the address, I'm coming. I want to figure something out here. Hold on a minute. I want to see if this address will change. The address have changed because we freed up the memory. I'm coming. I want to check something here. 3AC0. Okay, it is different. Don't worry. Don't let me use this. So it is always a good practice to what? To assign a null value, to assign a null pointer to that what? That's to assign null to the pointer. That's you just after freeing, you need to just say ptr is equal to null. Okay, in this case, that means what? This one will not have any address any longer. It won't hold any address. Should we try it out? So this is always a good practice. But even though you get rid of this, it doesn't really matter. You've already deallocated the pointer. We're using this free function. But they say it is always a good practice so that it won't keep holding that non-existing memory. Okay, let me just do this. What's the problem? So we are going to compile again. It's compiled and I'm going to execute. So you have two. So I'm going to do this and do this. So you can see address after deallocating is what? Is new. It's no more holding any address. Okay. Before it was still holding an address. Before we did not assign that null value to it. But even though it's holding that address, it doesn't have any data, any value inside it. If we try to print the value, okay, if we try to print the value of pointer after this, you will find out that there's no value inside it. It's just holding the address of nothing. Okay, so this is always a good practice. You just have to passing null to assign null to the pointer. I think at this point I will rest my case. I have a lot of projects to actually settle on. So is there any question? Question. See ya, let me walk up pass. Top man. Oh, Baba don't bounce. Hey. Okay. I hope you've been, even though it might really get a little bit overwhelming, I hope you've been able to at least get something, even though it's just a free function. You understand, you know how to deallocate memory, but and you definitely know how to allocate memory. Okay, it just depends on the kind of program that you want to write. Okay, it just depends on the kind of program that you want to write. At some point, even this using malloc will get more complex. at a point using malloc, it won't just come like the way I used it inside this program like this. You'll be having some kind of, in the case of where you have this, you are getting a kind of string from the user. For instance, the way you are going to have this, you are going to have another function that will help you to find the length of that string. Then that length of that string is what you are going to be passing here. Don't worry, with the, it's just that if you understand the basic principle, you just calm down, relax. All this thing is logic. You can, if you can think about it, if you can think of a way to, if you can think of the logic inside your head, then you definitely be able to write it out. Okay, if I should do this, just be try to interpret how to solve the question in English, in plain English first, without using any kind of coding terminologies, without having to say you want to write int, you want to declare a variable, you want to assign a value to the variable, you want to call the malloc. No, just try to like picture it down, write it down, break the question down in plain English first. Then okay, so we have a feedback form. So just tell us what you feel. If you feel this section was okay, I think I should stop recording now. Nobody should, yeah, that's, well, 2 hours 3 minutes.